Okay, good morning, class. Ayan. Okay, hello. A little bit of recall of what we did last two meetings. So, lesson 7. Oh, mali. Bigyan ko. Wait lang. Sa ibang course ko nalagay yung lesson natin. Okay, little bit of recall of what we did last time is, okay, so introduction, inalala natin kung paano natin iniisip yung mga itsura ng magnetic fields natin. Then, the lesson after that, um, we look, tinignan natin yung mga implications of having those fields on charges. So, the magnetic force on charges and currents. Ayan yung inaral natin. So, um, aalamin na natin kung saan ba nanggagaling itong mga magnetic field na to. How do they exist in the first place? Kasi nung mga naunang lesson, in-assume lang natin na nandyan na yung magnetic field. No, in-assume lang natin na, by the right hand rule, ganito itsura ng magnetic field. Okay, so paano siya mathematically? So, ayun yung lesson for today. Okay, we have this. Yeah, so, for today's topic, it will be sources of magnetic fields. Okay. Nakita natin na yung from previous lessons, pag gumalaw yung charge, pag may current, you will have a field. Okay, so the field of a moving charge is given by this. Okay, mu naught over 4 pi. Meron kang factor na ganun. Last time, meron tayong factor na 1 over 4 pi epsilon naught. 4 pi epsilon naught. For this, for magnetic fields, this becomes mu naught over 4 pi. Okay? Okay. And then, as you can see here, yung magnetic fields natin, katulad lang din ng tawag dito, electric fields doon sa dependence niya with distance. Okay? So, 1 over r squared, ganoon din sa electric field and sa magnetic field. Okay? Okay. And then, yung bago dito would be yung nasa numerator. So, tingnan nyo. Q, V, cross R. So, malaking problema siya kasi may cross product, di ba? Hassle. Okay, pero anuhin natin. Himayin lang natin para hindi tayo lost in life. So, V is velocity. Saan gumagalaw yung charge mo. Okay, and then R hat, yung unit vector, kung saan away from dun sa point na tinitingnan mo. Okay. Okay, so kunyari, meron kang charge. So kapag tumingin ka dito, tumingin ka dyan, yung R hat mo would be x hat. Assuming na meron tayong x, y axis dito. Okay? And then, kapag pumunta naman ako dito, at tinignan ko yung point na to, my r hat would become y hat. Okay. So, r hat is yung direction na radially away from the point of interest. Ayan. So, try natin yung mga, ano, try natin paano siya gumagana. Okay. So, two protons move parallel to the x-axis in opposite directions at the same speed v. Okay. Small compared to the speed of light c. Okay, kasi may implications kapag masyadong mabilis yung ano. Masyadong mabilis yung particle. At ano na to, advanced physics na to. So, we don't consider that. So at the instant shown, find the electric and magnetic forces on the upper proton and compare their magnitudes. Okay, so at this moment in time, kung saan nagtapat sila, ano daw yung makukuha nating magnetic field and ano raw yung makukuha nating magnetic force and electric force. Okay, so the electric force, F E is something like this, and FB would be QV QV cross B. Okay, QV cross B. So, kailangan natin malaman, alam natin mga Q, definitely. Yung E, madali lang malaman kasi this is the usual thing na charges lang naman. So, E is just 1 over 4 pi epsilon naught. Q over your distance is R. Arbitrary. Well, R lang din nakalagay doon. So, you have that. Okay, and then how is this done? B for that part, for this part. So, tingnan na lang natin si ano, no? Tingnan na lang natin yung pinoproduce ni Q sa baba. Tapos, tingnan natin epekto niya dun sa taas. Okay? Kasi, ganun din naman yung force. Parehas lang kung ano yung makukuha mo for both parts. Yung magnitude parehas lang. So, sufficient na yung kunin mo lang yung isa. Okay, and then magnetic field would be B is equal to Q naught over 4 pi Q, then V cross R hat over R squared. Okay. So, dahil ito ay pinoproduce nung nasa baba, pangalanan na natin silang 1 and 2. So, these are the fields that are produced by 1 and 2, ng 2 parehas. Okay? Tapos, ito si Q1. Okay? Alright. V cross R, what's that? So, V, ito, yung nasa baba. So, velocity sa baba is going x-hat. Tapos, i-cross mo siya doon sa tinitignan mong point, which is y hat. Okay, nakakalito siya, di ba? So, let's write it down para hindi tayo malito. 4 pi minus q. Okay, yung v ko is going, so, lagay ko na dyan yung magnitude ng velocity, which is v. Then, it's going x hat. And then, I will cross product it with yung direction at the point which I'm looking at. So, this is, yung direction dito is radially away from this point, which is y hat. Okay, so ayan, upward yung r hat. So, and then r squared. X cross y hat is just z hat. So, pi qv z hat r squared. Okay. So, ito ay doon sa point na tinitignan mo, z hat. So, nandito yung field pointing at z hat. Hindi nandito, no? Hindi nandyan. Kasi dito ka nakatingin sa point na to. What is the magnitude of the field there? So, pag ganun siya. Okay? It's going on the z hat. Sir, akala ko ba right-hand rule yung nagde-determine ng magnetic field? Okay, so pag tumingin ka sa baba dito, yung field mo naman, going negative z hat. Okay, actually pabilog yan eh. Pag tinuloy mo, pabilog siya. Okay. Kaya lang gagawin ganun for this case kasi isang point lang yung tinitingnan natin. Okay? We're just looking at the magnetic field at this point. Okay? So, kuwari, tumingin ka naman at the distance r in the z-axis, makukuha mong direction is pababa yung magnetic field. And we can try yung ano. So, at that point, ang makukuha mong v cross r, magiging x hat cross z hat. So, x hat cross z hat is just negative y hat. Okay, as expected, pababa. And then at the bottom, x hat cross negative y hat. So, this is just factor out mo yung negative sign, tapos z hat lalabas. Okay, so pabilog siya, pabilog. As katulad nung sinasabi natin right hand rule sa direction ng motion ng charges. Okay, going back dun sa kung anong meron sa pinagsasolve natin. So we have this magnetic field and then we're done. Not yet pa pala. Okay. So, ito, just to note it, this is V2, okay? Yung velocity ng charge, 2. This is Q2. Just to denote lang, para hindi tayo malito. Kasi dito magkakaroon ka ng V ulit sa force of the between the two charges, magnetic force between the two charges. So FB is Q1, V1, V2. Okay. So in this case, negative V yung direction niya. So let's plug in that. Q1, V1, tapos negative negative X direction yung velocity niya. Okay. And then ika-cross ko doon sa magnetic field na nakuha ko kanina, which is pointing towards the Z direction. So, B, Z, at. Okay. This is B2. Q1, V1, B2, negative X hat cross Z hat. X hat cross Z hat, that is negative Y hat, tas may negative sign ka, so that's Y hat. B2, Y hat. And then, yung B2 would just be the things that we have obtained there. Mu naught over 4 pi. And then, over R squared, Q, 2V2. Q2, V2, Z hat. Ay, wala nang Z hat kasi ginamit ko na yun. Magnitude lang pala kailangan. Ayan. Okay, yan. So you have that answer. For the for the electric force, simply enough, you can get this Q1 tapos 1 over 4 pi epsilon naught Q2 over R squared y hat. Okay. Okay. So when they are the same, the charges are definitely the same because they are protons. And ano man sinabi sa about the velocity? Same speed v. Then this further simplifies to u naught over 4 pi q squared v squared over r squared y hat. 1 over 4 pi epsilon naught q squared over r squared y hat. Okay. So that's that. Ano pa ba? Okay. Wala kasi mga values, ang hirap sagutin itong ano. Compare their magnitudes. What you can do is that kunin mo yung ratios nila. Okay, so ba't nawala yung Q1V? Kasi equal yung charge ng Q. They're both protons. And the same speed daw. So pinagsama ko na lang. Okay ba? Okay, okay. So Q1 is equal to Q2 daw. Kasi proton charge lang naman. Tapos V1 is equal to V2 daw. So we have that. Nagsama sila. Sorry, may tinatanong mo. Okay, okay. Good. Kala ko baka nasabi akong di malinaw. Okay, what we can do is compare their forces. So, compare daw natin eh. So, compare na. This is mu over 4 pi. And then Q squared, V squared. 1 over 4 pi. Epsilon naught. Q squared. R squared. Cancel, 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 cancel. Cancel, cancel. So, we are left with mu naught epsilon naught V squared. Okay. Ayan. Okay. Spoiler alert ito. This is a very small number. Okay, ayun na pala. Ayun pala spoilerless alert. Ay, spoilerless announcement. Okay, this is very small. Very, very, very small. Okay. Then, kung di ko matiis, spoiler ko na. So, itong mu naught epsilon naught is just equal to 1 over the speed of light squared. So, it's very small as compared to this. So, the magnetic force is much, much smaller than the electric force. Okay? Okay. Nice. So we have that. Alright, moving on. Since alam natin kapag mayroong moving charge, may magnetic field ka, syempre yung array of moving charge or a current, di ba, would also produce a magnetic field. So, magnetic fields are also guided by superposition, kaya nasabi natin na yung currents, they also produce magnetic fields. The combination ng mga charges lang naman yung mga current, di ba? Okay? So, wala namang difference. Ganun pa rin. So, ito yung infinitesimal ng magnetic field. Ang nangyari lang is that meron kang path, TL, kung saan dumadalo yung current mo. Okay? And then, cross R hat pa rin. So, yung R hat, ganun pa rin. Dun pa rin sa tinitingnan mo. Okay, so let's try this example. So, wala namang ganito sa exam, no? Pero, nice to know lang na kung ano man lalabas dito ayun yung mga ginagamit sa exam. Okay, anyway, moving on. dB must be equal to mu naught over 4 pi. And I is I, no? I talaga yan. Ang importante is makuha natin kung ano yung DL, tapos ano yung R, ano yung R. Okay? So, this is in the XY plane. So, therefore, yung R mo is just the square root of x squared plus y squared. So, I have x squared plus y squared. Wala nang square root kasi naka-square ito. Naka-square. Okay? R squared siya. So, pag pinlog-in mo to, mawawala yung square root. Okay, we have that. And then, DL is y hat. Tama? Direction ng current is upward lang. Wala na siyang pupuntahan na iba. Okay, y hat. Then cross, ito yung problema mo. Yung cross R hat. Okay? Okay. Pero madali lang ito kasi, di ba alam natin na yung cross product between two vectors, A hat cross B hat, is just A, magnitude of A, magnitude of B times sine theta, where theta is the angle between those two vectors. Okay, so we just do that here. Ay, sorry. dy ito, dy y hat. Okay, kasi dl vector yung kinukuha. Okay, so dl vector becomes like this, dy y hat. So I have here something like this, and dy. Ano yung magnitude ng y hat? So yung mga unit vectors mo, ang magnitude lang nila is 1. Okay? Magnitude lang nila 1. So 1 times 1 is 1. Then I need to have sine theta, which is the angle between them. In this figure, phi yung angle nila. Sine phi. And that is all over x squared plus y squared. Okay. Now, since my variables are in terms of x squared and y squared, I need to transform what theta is, or phi in this case, in terms of x and y. Okay. So, by geometry, malalaman mo na yung x component yung vectors na to, x component. Okay. X component nila, parehas lang. Sine is equal to the x component of sine. Okay? Yung magkaiba sa kanila yung cosine part. Okay, kasi evident naman. Evident naman na same lang yung height mo dito, yung x part mo. Pero dito, ang makukuha mo lang, pag ito ginamit mo, maikli. Pag yung cosine pi minus phi, ito siya. Ito lang yan. Pero yung cosine phi is something big. Okay. Okay. Anyway, wala yun sa point nung ano natin. Ang point is, by geometry, you get this guy. Okay? And bakit natin gusto ilipat sa ganito? Bakit hindi na lang sin phi? Kasi mas intuitive sa atin maggumamit ng right triangles, no? Kasi nandito yung ano eh, nandito yung merong right triangle eh. Okay, so by that, magagamit mo na yung sin pi minus phi opposite, which is x over hypotenuse, x over r, so that's square root of x squared plus y squared. And then I just use that up. U naught I, sorry, 4 pi. Okay, and then x over x squared plus y squared. Okay, ito ay power ng 1. Tapos plus, meron pa akong extra 1 half, so that's 3 halves. Yung x ko sa numerator nanggaling lang dito. And then I have dy. Okay, and nice. And then I would just okay, ano palang ano nito, direction nito, nakalimutan ko ilagay. So y hat cross r hat, and r hat is in the plane of xy. Therefore, ang direction niyan ay negative z. So this is negative z. All right. With this, you can now find the magnetic field. The magnetic field is just the integral of this over 4 pi. Integrate mo kung saan tatakbo yung y mo. So that's coming from negative a to a. Negative a to a. X over x squared plus y squared dy d halves z hat. And then we're not gonna do the integral. You just use your table of integrals to do this. Okay? Hindi naman kasi kayo magsosolve ng ganito sa exam nyo. Okay na. Nice to know na lang. Pero baka kasi mamaya may paggamitan kayo. Diba? Okay, so with that, ang lalabas na value doon sa integral na yun would be this guy. And then again, if a is much larger than x, what happens is that u naught I over 4 pi to a, and then x, yung nasa loob ng square root would look like a squared kasi mas malaki siya kaysa sa x, no? Nang sobra-sobra. So yung nasa square root na yun, mukha na lang siyang a squared. And this cancels out with this, and you're left with this guy. Okay, so 2 divided by 4, that's 2 pi x. Okay, yung x is just the distance from the conductor. And it's nice to replace it with r by notation lang. It's nice to do that. Okay, so this is the magnetic field of a long. Okay, so kailangan siya long. straight current carrying conductor. Okay. So let's try another example. This figure below is an end-to-end end-on view of two long straight parallel wires perpendicular to the xy plane, each carrying a current I but in opposite directions. Find B at points P1, P2, P3, and find an expression for B at any point on the x-axis of the right of wire 2. Okay. So, ano ang kailangan natin malaman? Ano raw yung field sa 1, P1, P2, at P3. Okay, so gagamitin natin yung nakuha natin na mu naught I, 2 pi r. Kasi this is a long, straight wire. B is mu naught I over 2 pi r. Okay. Sa'yo naman ito, walang values yung ano. And ito pala, may values pala. Nandito yung values. Okay. So, 3D yung distance ni P1. And then 2D ang distance ni P3. Okay. Alam natin na right-hand rule, this becomes yes, the wire 1 produces a magnetic field that rotates counterclockwise. So downward there, upward in this place. Okay. And wire 2, by the right-hand rule, rotates clockwise. Okay. So this is fairly straightforward. At P1, R is equal to Q. So B total will just be adding B1 and B2, contributions ng B1 and contributions ng B2. Okay, for B1, itong wire 1, kita natin by this drawing, napababa yung magnetic field at that point. Therefore, B1 is mu naught over I 2 pi times yung R mo, which is D, 3D minus D. Okay. Distance from wire to that point. So that's 2D. Okay. And then plus the contribution of the other one, which is mu naught I over 2 pi. Okay. But plus, actually hindi plus to. Okay, hindi siya plus. Negative yung makukuha mo dito. Actually, let's be consistent. Negative yung nandito sa una kasi downward. Downward to. And then the positive one is the on the second term sa B2. Okay? Kasi makikita mo, i-extend mo to sa dulo, upward yung makukuha mong field. Okay? Okay. So the distance of wire 2 from P1 is 3D plus D. So that's 4D. Okay, and then positive. Okay, so this is what we have. Okay, hindi natin simplify. Naintindihan naman. Then at P2, which is this point, the middle point of the two. Nicely enough, at P2, they all point upward. 3 points upward. Okay, so therefore they would just add normally. Total is just mu naught over mu naught I for pi, tapos ito distance d, tapos the other one is also that distance. Okay, so they would just 2 pi. Bakit 4 pi gamit ko? 2 pi. Sorry. Okay, 2 pi. And then lastly, which is yung 0.3, which is there, at P3, ganun pa rin yung gagawin mo. D total is just 2 pi times some distance. Distance ng wire 1 to 0.3 is 3D. Tapos yung isa ay D. 3D plus D. Okay, ngayon titingnan mo yung direction. So si wire 2 would be negative. And then si wire 1 is upward at this point. So ito yung negative. Okay, so you just add them up. Find an expression for B at any point on the x-axis to the right of wire 2. Okay. So therefore, yung magnetic field that is produced by each one is, let me write this down. Mu naught I 2 pi x plus d. Okay, ito yung pinoproduce ng wire 1. Okay? So at x is equal to 0, pansinin nyo, x equal to 0, nandito ka sa gitna, ang pinoproduce niya is this much, okay? 2 pi d, yun yung distance niya, diba? D. Okay, and then the direction is always upward. Now y hat. And then B2 would be mu naught I over 2 pi Okay, so titignan mo lang din ulit yung direct yung field at point 0 kasi doon madali ma-determine kung na expression na. So at this point naman, okay. Parang nakakalito yun. Mas maganda pala tignan yung field at distance P3. Okay, at distance P3, alam natin na yung at distance P3, 2D. At distance 2D, alam natin na yung field ay may plus some variable ka dito. Lagyan natin plus I, wag B. Plus, ano yung magandang variable? X prime. Okay, hinahanap natin expression pero hindi natin maano. So, wag natin isipin ng maigi. Gamitin natin yung kung ano meron tayo. Solve na natin yung B2 at point DD, point P3. So, that is given by this guy. So, negative mu naught I. Okay, negative mu naught I over 2 pi D. Negative mu naught I, 2 pi D. Okay? So, this tells us that yung plus x prime ko dito is actually minus D. And then I have a negative y hat direction. So, this is x minus D dapat. Okay, so kapag pinlog-in ko si 2D dito, makukuha ko yung expression na ito. Tapos, negative y hat. Alright. Okay, now we are ready to combine them. So, B total for all points on the right of WAR2. Okay, ayun yung tanong sa atin, nasa right ng WAR2. Kaya din ginamit natin si P3 for example. Okay, makukuha ba natin si yung B1 at P3 kapag pinlog-in natin si 2D dito? Kasi ginawa natin for B2 pero hindi natin ginawa for B1. So, kapag pinlog-in mo dito si 2D sa X, magiging 3D ito. And positive pa rin naman. Positive pa rin naman. So, therefore, tignan natin yung nakuha natin. So, ayun pa rin. Okay, nice. Tama yung ginagawa natin. So, the B total now is mu naught I over 2 pi. And then I just combine those two. So this is 1 over x plus d plus 1 over x minus d. This is actually minus. Minus ito. And then times y hat. Okay, am I getting things right? Okay, check ko lang. Okay, tama naman ang ginagawa natin. Okay, so combine lang natin mu naught I 2 pi and then if we combine this guys, magiging denominator ay x squared minus d squared. Tama ba? Okay, magka-cancel lang kasi yung middle terms. xd minus xd. Okay. So the numerator becomes x minus d minus x minus d. So that becomes minus this. Okay, so we have mu naught I over pi d over x squared minus d squared negative y hat. Okay. So this is the answer. Nasanay lang ako na pwede nyo naman ilagay negative doon sa unahan. Nasanay lang ako na nilalagay ko siya sa direction ng nasa unit vector para mas intuitive sa akin yung itsura nung bagay natin. Okay. So ito yung magnetic field. Yung legit na itsura ng magnetic fields. Okay. Siyempre, it continues. Nice. Okay, let's have a different example now. Kanina kasi puro straight wires lang ginagawa natin. What if we curved the path of the current. So, ganun pa rin. Let me just type in dB. So, that is mu naught over 4 pi, mu naught I. Constant naman lagi yung si I. Then, for your case, no, dl plus r hat. And then r squared vector. The r squared vector in this case is is constant. No? R squared dito would be a squared. Tama ba? A squared. Square root ng a squared plus x squared. So this becomes, let us write it explicitly. So this is x squared plus a squared. Nawala na yung square kasi square root ito. And then dl, okay, the path of dl is, okay. Iisip ko magpo-proceed tayo dun sa mahirap na way. Kasi hindi nyo naman kailangan in life. Sige. Pwede. Okay. Okay. So, i-consider muna natin itong maliit na element na nandito. Okay? So, maliit na element na yan, napansin natin na yung current natin, let's recall the current, it's going counterclockwise in the YZ plane. And then at this point, it's going to the left or to the negative or to the Z hat axis. To the Z hat axis. Then yung at this point, the R hat direction is towards like this. So yung so meron kang pag ganun, no? Tapos meron kang pag ganun. Okay. By the right hand rule, yung lalabas na magnetic field dyan is this part. Tama? And of course, as usual, you can break this down into two parts, which is yung x and yung y. Okay? Yung x mo and then yung y. Okay, so by geometry, this is theta. Okay. Hindi ko alam paano nyo ini-imagine yan, pero ang ginagawa ko pag ini-imagine ko yung mga ganyang bagay, ganito. Well, di ba may XY plane ako? Okay, ito yung side view, no? Ito pa rin yan. Tapos meron kang vector na ganito. Tapos meron kang ganyan. Tapos may theta ako na ganito. Theta rin ako na ganito. Okay. Para lang masatisfy ako na legit to. Na legit to. No? Ginagawa ko, sinasarado ko yung theta. Okay. Sinasarado ko yung theta. What I mean is, so pag sinarado ko yung theta, a-adjust lahat ng bagay. Wala tong kinalaman sa magnetic field, guys, na in-explain ko lang paano ko siya iniisip. Paano ba yung by geometry na yan. Pag sinarado mo siya, so, papalitin mo yung theta dito. So, yung blue line mo, tataas siya pa ganito, pa ganyan, pa ganon, pa ganon, hanggang mapunta na siya sa vertical axis. Nagets ba? Mula dito, tataas mo, hanggang sa maging vertical na siya. Okay, pag naging vertical na siya, anong consequence nandito sa kabilang blue? Nakaganon na siya. Okay, so nag-fit dun sa axis mo. So therefore, legit nga, pag ginalaw mo ulit yan by theta, pag ginalaw mo yung L na yan by theta, kung ano man makuha mong angle, So, pag ginalaw mo lang siya ng onte, meron kang angle na ganito. So, meron din siyang angle na ganito. Kasi proportional dapat. Kasi maintained dapat yung shape nila. Wala lang, some way to think about it. Okay. So, wala lang. Share ko lang. Anyway, kanya-kanyang pag-isip yan kung paano maisipin yun. Na theta nga rin yun. Okay? Okay. And then, okay. So with that, alam natin si dB nandito. Then we can break it down into x and y. X and y counterparts. Okay. So yung DL naman at this part. So pag umikot na ako, nakapunta na ako sa part na to. Okay. So by doing the same thing, ang mapapansin ko naman, babaliktad lang lahat. Babaliktad lang lahat. Okay. So may dB ako dito. May dy din ako dito. Mapansin mo si dy, they cancel out. And then kapag napunta na rin ako dito sa part na to, at sa part na yun, dito sa left sa z, and right sa z, yung dz na part, yung dbz na part, tsaka yung sa negative dbc, they are equal. Okay, so what we need is just the cosine of db para makuha lang si x. So db, see this, db cosine theta, and then this is equal to yung cosine theta ko is adjacent over hypotenuse, diba? So adjacent ko is a over hypotenuse x squared plus y squared. A squared pala, a squared to. Therefore, this is just mu naught I over 4 pi in A okay. So this is still DL. Wala namang bago. Kinuha ko lang yung cosine. Yung DL cross R hat nga lang. Wala na tayong ano dyan kasi kinuha na lang natin yung x direction. So x hat na lang yung direction natin. And then the denominator is again 3/2. Okay. And then this is easy to integrate. So the integral of this, so yung DL as is yung integral mo, since alam mo yung DL, alam mo yung path ng circle, di ba? The path of the circle is just 2 pi A. Okay, the circumference. Okay, kasi wala nang tayong i-integrate, wala naman tayong L. Wala tayong L. So x squared, hindi nagbabago si x. Same distance lagi si x. Same distance lang lagi si y. Kasi radius siya ng circle. Therefore, B has to be. B has to be mu naught I over 4 pi. Yes. And then this is 2 pi A. So that's 2 pi A squared. May A squared kasi may extra A tayo na. Tapos x squared. A squared. 3/2. X hat. Did we get that right? Mu naught I A squared. And mu naught I A squared 2 magiging 1/2 na lang. Cancel pi. Meron akong 2 sa baba. Tapos x squared plus a squared 3/2. Okay. Okay. So what if hindi natin ginawa yun? Ano yung other ways, no? Ano yung other ways? Ano yung mahirap na way? So yung DL na path is just A. Kailangan natin makuha yung arc length, di ba? DL is just arc length. D theta. Ay, si theta ba yung gagamitin natin? So huwag natin gamitin si theta, no? Phi gamitin natin. So yung phi is the angle around this part. So phi. Tapos DL. So this is phi hat cross R hat. Okay. And then this becomes U naught I A for pi. Okay. And then DC. Tapos may sign theta ka. Kasi dahil dito sa cross product nila. But the cross product isn't very straightforward to you guys. Kaya hindi natin dinaanan yung part na yun. Okay? So hindi siya very straightforward sa inyo. Okay, so yeah. But we can, let's get try to get the magnitude. Yung sine theta is just opposite over hypotenuse. So, meron pa ako extra unit vectors dito na di natin alam na. So, lagay lang natin si phi cross r. Unit IA. Tapos, wala na to, hindi na kasama sa pinag-aaralan. Curious lang ako how it would turn out. Then, this is just x squared plus a squared. 3/2 ito. Kasi hypotenuse is the same. Bago lang yung okay, so yan. Ito yung mahirap na part kasi meron pa tong breakdown in terms of phi. Okay, kaya hindi pa natin siya ma-solve ngayon. Okay. So, hindi siya ma-solve ngayon. Kasi, it will take time to break this down. But this is, yung r hat ko will break down into two terms. Okay, will break down into two terms. Nakadepende rin siya sa angle. But the d phi is straightforward. Pag integrate mo, may lalabas na 2 pi. Okay, may lalabas na 2 pi. Anyway, wala lang. Curious lang. Pero huwag natin gawin. Sayang oras. Okay, anyway, this is your magnetic field of a circular current carrying loop. Okay, and then if you want the maximum field, punta ka sa x equal to 0. Okay? Sa mismong origin, center ng circle. Punta ka doon, you'll get the maximum. Okay, and when we do that, let's get the maximum. IA squared, 2 times a squared, 3/2. And then this guys, magiging a cube ito. A squared over A cubed. A squared over A cubed becomes mu naught I over 2A. So for a single wire, we have this magnitude of field in the center of it. Okay? And then what if meron kang N circular current carrying loops? Okay, so nirolyo mo pa ng maraming current diyan. So, ang nangyayari is that mag-multiply ka lang ng number of loops. Okay. Ito yung efficient way of making magnetic fields strong. Kasi kapag isang loop lang, anong mababago mo sa kanya? Anong mababago mo dito? Dilitan mo yung A. Okay, so geometry. Or tatasan mo yung current. Okay. If you want A to be constant, then no choice ka. You have to increase the current for a single wire. Siyempre, hindi naman pwede masyadong mataas yung current kasi it would burn your conductor. Matutunaw yung conductor. Yan. Kaya nagkakasunog. Tumataas yung current. Pag yung extension wire sinasaksakan ng maraming bagay. So, tumataas yung current sa extension wire tapos umiinit siya. Kaya siya nasusunog. Okay, anyway, yan. Kung gusto mo mapalakas yung field, we just rorolyohin mo na lang siya para instead of increasing I, you would just increase the number of loops, the number of turns that you can do. Okay, so this is again in the terms of exact direction. Okay, okay. Now, ang hassle mag-calculate ng magnetic field kasi may mga cross product ka nagaganap. Okay. What if we have something like Gauss's law for magnetism? I mean, yung method na madali. Kasi dinignan natin yung Gauss's law for magnetism. Pag ginawa mo yung Gauss's law for magnetism, wala ka nakuha. Zero siya. Diba? Pag in-enclose mo yung magnetic field, lahat ng lumalabas na magnetic field, bumabalik din sa kanya. Makikita nyo dito. Lumalabas, tapos babalik siya. Okay, so pag in-enclose mo to sa area, hindi mo makukuha yung number of field lines. So that wouldn't tell you the magnetic field. So what else can we do? No? So we have here Ampere's law. So yung Ampere's law parang ito yung easy way to calculate the magnetic field. Okay? For this case, for Ampere's law, the left-hand side is B.dl. Okay? Tapos closed integral yan. So ibig sabihin, closed dapat yung path. Then that must be equal to mu naught I enclosed. Okay? Enclosed by a path. Okay, mahirap imagine yung mga bagay-bagay na nandito. Kasi from Gauss's law for electricity, things are very straightforward. You have a sphere. What do you need for a Gaussian surface? You also need a sphere. You have a cylindrical configuration of charges. The Gaussian surface that you need will be a cylinder. Okay. Madali. Straightforward siya. However, sa Ampere's law, hindi. Okay. So, yung DL, the Amperian loop, as we call it, the Amperian loop DL, yung basis niya is that doon dumadalo yung magnetic field. Okay. So, for a straight current carrying wire like this, aalamin mo muna kung paano dumadaloy sa kanya yung tawag dito, magnetic field niya. So, dapat meron kang hint kung ano itsura ng magnetic field niya to do Ampere's law. Okay? So, we know that the magnetic field for this guy is rotating around its axis. So, therefore, ang Amperian loop na gagawin mo for a straight wire is that, try natin for straight wires. Okay, imagine natin kung ano itsura ng field. Meron akong current kapag ganun. So, right-hand rule lang. Gamitan natin siya ng right-hand rule. Makikita natin that the magnetic field rotates around it. So, with that rotation, yung DL na gagamitin mo, Amperian loop, circle. Okay? And that circle would follow the path of the magnetic field. Okay. So with that, B dotted with DL becomes simply, kasi B dotted with DL. So in that product, if parallel kayo, magkasunod kayo, you're following the same path, you would just B times the length. Okay, the total B times the total length. Okay, for this case, circular yung path natin, so this becomes 2 pi r. Okay, r is a variable. Kahit ano, gaano kalaking Amperian loop gagamitin natin, okay lang. Small Amperian loop, okay. Then the right-hand side, mu naught I enclosed. Okay, mu naught I enclosed. Ano ibig sabihin yan? Kung ano yung na pumapasok doon sa loop mo. Okay, so ano yung pumapasok doon sa loop mo? Yung sa Gauss's law, it's very straightforward ng charge enclosed. Kasi charge enclosed is na-enclose talaga siya dun sa surface mo. But this time, it's not very straightforward kasi you'll have to look into the loop kung ano nakukuha mo. Okay, so the Amperian loop here is a circle, and what passes through that circle? Okay, so this amount of current, so let's say it's I, mu naught I, mu naught I. Okay, and then since these two are equal, ito siya, di ba? Yan siya. These two are equal. Therefore, B times 2 pi r must be equal to mu naught I. And we can now find B. Mu naught I and then over 2 pi r. Ito ba yung nakuha natin kanina? Tingnan natin. Saan yan? Ayun, di ba? May nakuha natin. Okay. So can we do Ampere's law for this? Hindi. Hindi, kasi mahirap imagine yung field niyan. Okay, mahihirapan tayo. May mga piling may mga piling tawag dito. Configuration lang wherein you can use the Ampere's law. Okay, so let's try this example. A cylindrical conductor with radius r carries a current I. Ay, hindi ko nalagay yung picture. Basically, yung conductor mo hindi na siya wire. It's a cylinder. So thick na siya, makapal siya. Okay, and then the current is now uniformly distributed over the cross-sectional area of the conductor. Walang sense of pag over the volume, no? Paano mo i-imagine yun? Nag-gets ba kung bakit walang bakit hindi siya over the volume? Kasi mga currents are in a straight line, di ba? So, kapag tinignan mo yung current, ito yung conductor mo, cylinder conductor, what is the sense of having it over the volume if your current is made up of lines? So, cross-sectional area, makes sense, di ba? May into the page na current. Okay, makes sense na by the area. Yan siya. Pero over the volume, it would not make sense. Anyway, continuing on. Find the magnetic field as a function of the distance r from the conductor axis for points both inside and outside the conductor. Okay, simple enough. So, kuwari ito yung conductor natin, tapos by the right-hand rule, the magnetic field rotates around it. So, yan. Okay, so with this, for r greater than capital R, so R, then things would be simple. So B times 2 pi R. Okay, itong blue line natin is 2 pi R. And R is greater than R, capital R. So it must be mu naught. What is the current? Okay, carries a current I. So the total current na may enclose ko is yung whole conductor which carries a current I. Therefore, I have this. So B is equal to mu naught I over 2 pi R. Okay, so kamukha niya yung normal na wire. Ang bago lang dito is yung kapag tinignan mo yung loob. For R less than capital R, let's have a boundary here. Okay. For R less than R, what can we have? Nasa loob na tayo ngayon ng conductor mo. Somewhere here. Gawa tayo ng Amperian loop inside. The left-hand side is still the same. The left-hand side is still the same. Okay, kasi bilog pa rin naman yan. Bilog pa rin. Ganun pa rin tsura ng magnetic field inside. However, the right-hand side is not very straightforward because mu naught I enclosed is not straightforward. Okay, so I enclosed would be the total I. So kukunin ko lang yung percentage na nakuha ko. Okay, so the percentage is just titingnan mo kung saan yung distribution niya. So area yung distribution niya. Therefore, the percentage must come from an area. So we have the total, which is the total area of the cross-sectional area of this cylinder, which is pi r squared. Then what I have is this. So the amount that I have is this. Na-enclose ko. Okay, so ano lang to? Percentage lang ito. Okay. So kapag 0 yung R ko, wala dapat ako ma-enclose na I. Okay, and then kapag nasa R na ako, ma-enclose ko na lahat ng current. Okay, therefore, I have my B to be mu naught I. Magka-cancel na yung pi dito. 2 pi R. Tapos R squared over capital R squared. So this is mu naught I R 2 pi capital R squared. 4 points inside. Okay. Let me just check that if I was doing it correctly. Okay. Correct yung ginawa natin. Alright. So that's for the cylindrical conductor. Okay. And then, let's try here something. Okay, yung circular na loop, hindi natin kaya to kasi medyo magulo yung field nito. However, if we are to have multiple loops, such as this, okay, solenoid ang tawag dito. Solenoid. So maraming loops. We can actually use Ampere's law for this. Assuming that this guy is very long. Okay, and we're just interested in the field near its insides. Okay? So we're not interested in the magnetic field yung sa medyo edges niya kasi magulo yung magnetic field. Okay. So with this, ito yung inside view, central part. Okay. So we have this. Mapapansin mo, by the right-hand rule, itong current dito, yung X, di ba? Yung X is into the page. Therefore, by the right-hand rule, pag ganyan yung magnetic field mo. Ng single lang. Okay. So if you are to continue it, yung nasa loob, it would look like a straight line. Okay, it would look like a straight line. And then sa labas, parang dapat pabaliktad, no? Pabaliktad dapat. Okay. So hindi pa natin alam kung ano yung field outside. Okay. At points outside, solenoid. Points outside solenoid, try natin gumawa. Ano? So, kunyari, ito yung solenoid mo, tapos Amperian loop ako na square din. Yes. Okay, kunyari square yan, guys. Hindi lang maayos. Tapos, sabi natin, alam natin na paganto yung, dapat sa tingin natin, paganto yung field just outside. No? Kasi parang na-imagine natin na if the solenoid inside is here, pag ganyan. Okay, dapat babalik na pag ganun, no? Dapat babalik na pag ganun. Di ba parang yun yung nasa intuition natin? So, let's have that intuition first. Then, let's try to do the Amperian loop just like here. Okay, so for this Amperian loop, lagyan natin ng this is at point A, this is at point B. Okay, and then let's have this guy's length to be L. Lagyan lang natin dimensions para hindi tayo lost in life. Okay, so doing this Amperian loop, I have here B times L minus B times I. Wait, lagyan natin. So, hindi natin alam si B. So, B at the magnetic field at A, at point A. So, the field line here is multiplied by L. Then minus the magnetic field here at B times L. Okay? So, length lang. Diba ganun yung Ampere's law. And then, equals 0 kasi wala naman tayo ina-enclose na current dito. Okay. So, B at A. Okay. Dito multiplication function to function. Must be L is equal to B. L. Okay, nalipat ko lang sa kabila. So, bakit negative yung nasa taas? Kasi, ang hula natin, that the field is going to the right. So, kung sino man going to the right, siya yung parallel with B. So, ayun yung positive dapat. So, ayun si B at A yun. Okay? And then, for having this, we know that the field at A must also be the field at B. Okay, now look at this. At B, Parehas lang daw yung field ko here and here. Okay. So, yung fields natin, they are in terms of usually 1 over r squared. So, at infinity, this goes to 0. Okay, at very far points. Okay. So with this, mapansin mo na kapag yung Amperian loop mo ginawa mo malaki such that B is far, magiging 0 siya. And that implies also that yung malapit lang din, it would also be 0. Okay. So kuwari, dagdag ka ng Amperian loop. Dagdag ka ng Amperian loop at point C, and tatasan mo rin at point D. Okay, hanggang makaabot ka ng infinity, mapansin mo, yung at infinity na. Okay, less than infinity. Ito, 0 na yung magnetic field mo. So, dapat 0 din dito. And kung continue mo, 0 din, 0 din. Hanggang makaabot ka sa A, 0 din. Okay? This tells us that the magnetic field outside the solenoid is just 0. So, akala ko babalik. So, yung pagbalik nung magnetic field, it's not very straightforward. So, yung sabi ko nga, yung field dito sa edges dito, magulo yan. So, higher physics na siya. Pero yes, ano pa rin naman. Turns out na yung going out equals pa rin sa going in dito sa kabila. Okay? So, again, that's beyond our point now. Gusto ko lang i-point out na yung bakit 0 ito. Okay? Outside the solenoid, it's just 0. Okay. Now, we're ready to find out what the magnetic field inside. So, yung Amperian loop mo naman for this case, ipasok mo lang ng konting iba. Okay, so I have this. So, B times the length of huwag natin lagyan ng parenthesis. Length must be equal to the enclosed current. So, mu naught I. Okay. So, yung ma-enclose mo na current dito is nakadepende kung gaano karami yung loops na tatamaan mo. Okay, so each wire contains a current I. So, therefore, kung ano yung ilan yun na enclose mo, sorry, wala ako sa train of thought ko. Multiply mo yung I with the number of loops that you have. Ayun, loops. Okay. So for this, kailangan mo is the number of turns per length. Okay. Okay. If you have this number of turns per unit length, let's say that's n, then you have this kind of you have that kind of notation, then bibilangin ko yung mga number of currents ko dito times I, tama ba? Okay. And then B becomes U naught N I over L. And then this guy, sabi nga natin, meron tayong tinatawag na number of turns per unit length. So this is just U naught N I. Okay? So Buni. Okay, Buni. So ayan yung magnetic field na sa loob ng solenoid. And outside, it's just 0. Okay? So, kailangan itong N dito is turns per unit lang. Okay. So, I guess that's it for today. Pero may asing topic, basahin nyo lang. Magnetic materials, paramagnetism, diamagnetism, ferromagnetism. Bakit hindi natin ito diniscuss? Kasi puro words lang sila. Magaling na kayo doon. Wala namang bago doon. Pero pwede naman kayo mag-consult. Things are not very easy. Okay, kasi dito sa part na to, ang bago lang is that sa electricity natin, meron tayong epsilon naught, which became epsilon dun sa meron sa mga dielectric na, no? For this part, magkakaroon din tayo ng ganun. Magiging mu na siya. Okay? Kapag nasa magnetic material ka na. Okay, and mu, in this case, minsan nagiging negative siya. And then minsan nagiging positive. Negative siya pag diamagnetic material, then positive pag paramagnetic at ferromagnetic. Okay, for epsilon, it's not the case kasi positive lang lagi yan. Positive lang lagi siya. Okay, I guess that's it. So, any questions, guys? Any questions? Marami pang example sa libro nito. So, ayun naman usually ginagamit sa mga tanong sa libro, ay sa exam. Gamitin mo na lang yung equation. You just plug things in. Meron pa tayong tinatawag na toroid. Ito solenoid siya. Solenoid. Meron pa tayong tinatawag na toroid. So, yung toroid, ang itsura niya, itong solenoid, i-continue mo siya such that magiging bilog siya. Okay. Tutuloy mo pa bilog pa ganyan. So, mukha siyang donut. Solenoid lahat ng bagay. Okay. Ayan. So, yung field dyan, madali kasi umiikot lang yung field sa loob, di ba? Umiikot lang sa loob yung magnetic field. Anyway, that's it. That's it for hindi natin ginawa wala tong computation kasi merong isang equation sa libro which is this one, B naught for paramagnetic materials. U naught M. Okay. So M is just the magnetization of the material. And as you can see, lumalakas yung magnetic field. B naught, dadagdagan mo siya nito. For paramagnetism. So paramagnetism helps your magnetic field. Alright. For reals na talaga. Teka, bigyan ko kayong bonus. Dalawa na lang kayo dyan.